Okay, Bismillah ar-Rahman ar-Rahim. Now we'll do section 2.2. I'll go quickly over it. What I will do, it's not easy to have questions about 2.2 in the exam because you need the tables, you need the graphs. So I'll try to do my best to go over it quickly. Mainly what is in 2.2, we have the informal definition of the limit. What's the meaning of the limit? It means as x approaches a, as x gets closer and closer to a, I don't care about a. What will happen at a? Or not equal to a. It's not my business. What is the value f of a? Just I'm checking as x gets closer and closer to a. The value of x gets closer and closer to another value, L. So we say the limit as x approaches a of this function f of x is equal to L. There are many ways to do it. In this section, we'll talk about numerical way, which is through the tables, collecting table of values. Graphical way, where we draw a graph, we can check it, and then we can check the limit. In 2.3, we'll do the analytical way, which is use algebra or calculus to do it. These are the cases where the limit, we will say the limit does not exist. Like in this case, f of x equal 1 over x squared, as x approaches 0, in this case, as x approaches 0, this function has no limit. I cannot find a value where this function will reach. So we say the limit does not exist. The same thing here, absolute value of x over x. If you have the function, you notice the limit does not approach a real, the function does not approach a real number at 0, because from right it's 1, and from left it's -1. So at 0, I mean, I cannot say as x approaches 0, I am where? I am in this side or in this side. So we cannot tell. So we say the limit does not exist. With another function, square root of x -1, as x goes to 1, same problem. From right, yes, everything is defined, we have no problems. But from left, as it goes to a from left, I know that in x -1 should be greater than equal to 0. So from left, this square root of x -1 will be undefined. So we're saying here also the limit does not exist. Right not equal to left. There is this special function sine 1 over x or sine pi over x, 2 over x, all of these functions, the same problem. Now this is will oscillate. The function will oscillate between -1 to 1 as we are approaching 0. It will not reach a specific value. So these are the three cases mainly. The limit will increase without bound, like going to infinity, right not equal to left, and the last things oscillate. This is the same thing, right not equal to left. So these are the three cases, as I said. We have different number, approach different number from the right side of C, then from the left side, increases or decreases without bound, going to infinity or minus infinity, oscillates between two fixed values. Also, we define what's called limit from left, limit from right, the same idea, but now I'll check the limit. I'll check the behavior of the function as I'm approaching a from left. This is, they call it a minus. I want to see what the function will approach what. Like in this case, it will approach L as I'm going to a from left. This the right way, the right side, x goes to a from right. So we say as x approaches a from right, the function is going to L. As approaching a, x value is approaching a, the function is going to L. The limit exists if from right equals from left, if both are equal. Both limit exists and they are equal to the same value. Does not exist if right not equal to left, then the limit does not exist. For example, this function, if you notice, if I go from left 0, I'm on this side. From right 0, I'm on this side. So the limit here does not exist. And I mean, if t goes to 0 from left, it will be 0. If the function approaches t from right, it will be here. It will be 1. So these two limits not equal, so the limit does not exist. Left not equal to right. These are questions which we need to solve. X goes to 2 from left. 2 from left. It will be in which function? It will be in this function? No. It will be in this function. So the limit here will be equal to 3. 2 from right. Or 2 from right. I'm going from this side, so I am in this function. It will be 1. So what will happen to the limit x goes to 2? It will be does not exist. Because left not equal to right. What about at 5? 5 from left. 5 from left. I will be in this point? No, I will be here. Somewhere here. So that value will be what? 2. 5 from right. 5 from right. I will not be at this point. I will be here. Somewhere here. So it will be 2. So what will be the limit? Since these two are equal, that will be 2. I think this explains everything here. And these are the solutions. Okay, I don't care about G at 5. Same thing, another question. Now, what is x goes to 1 from left? 1, this is 1 from left, from here. I am where? I am in this side, so it will be 1. 1 from right. 1, but from the other side. So I will be here, somewhere here. That will be 4. So it will be x goes to 1, does not exist. Now minus 4, I'm talking about minus 4. Minus 4 from left. From left, it will be minus 3. Okay, it will be, yeah, it will be minus 3. Minus 4 from right, it will be also, I will be here somewhere, so it will be minus 3. So what is the limit as it goes to minus 4? It will be minus 3. And these are the answers. 3, oh no, 3, I mean here, sorry. Yeah, we are here, 3, it's 3, not minus 3. So this is 3, 3, and this is 3. Yeah. Another one, x goes to 2 from right. 2, 1, this is 2 from right. From right, so I'm going from this side. I am not here. This is from left. This is from right. So it will be what? 1, 2, 3. This is 3. Minus 3 from right. Minus 3. 1, 2, 3. This is 3 from right. So it will be where? 0. Minus 3 from left. Minus 3 from left. I will be here. That will be what? 1. Here this is 0, minus 1, minus 2. X goes to 4. Where is 4? 1, 2, 3, 4. 4. It will be here. No. 4 means I'm going to this side, or from this side, I'm going to this value, which is 2. So this is will be 2. Yeah. Oh, sorry here. Yeah, here, what I did, I saw it only going from right or from left. No, here x goes minus 3 from right. This is what I did. It will be what? 0. Huh? From right, it will be 0. But from left, it will be what? Minus 2. Because of that, the limit does not exist. Sorry, I was thinking, I'm doing it only from right. I did not notice there is no sign. So it's minus 3 here. 4, it will be 2. For sure, it will be 2. Yeah. I said this because they check left and right. Huh? They need to check left and right. Okay. X goes to 1 from right. 1 from right. 1 from right. More than 1, I will be here. So it will be 1. 1 from left. 1 from left. Here, I will be there. I will be somewhere here. So it will be 2. So it will be this limit does not exist. 2 from right. 2 from right. 2 from right. I will be here? No, I will be somewhere here. So that will be 1. 2 from left. Same idea. It will be somewhere here. So it will be 1. So at 2, limit as it goes to 2, it will be 2. It will be 1. F at 2 is 2, but we don't care about F at 2. We care about the limit. As I'm approaching 2, it will be either here or there, and that will be always 1. Goes to 0 from right. 0 from right. It will be 0. 0 from left. It will be 0 also. So if x goes to 0, for sure it will be 0. I have the answers, yeah. It should be the same. I think so, yeah. Okay. Which of the following choices about this function graphed here is true? Limit s goes, I know this is the correct answer, but let me do it backward. S goes to 0. X goes to 0. X goes to 0 from this side or from this side. I'm going to 0. So this is not 1. This is 0. X goes to 1. 1, right, not equal left. Huh? Right will be here. Left will be here. So this does not exist. 0, we said it's 0. So this is wrong. Goes to 1, we said it does not exist. Huh? But we notice something also. Any value, and this is part A, any value between -1, if you take any value, the limit always exists. Any value, if you take a value here, left equal right, value here, left equal right, any value between -1 and 1, the limit exists. And this is what he's saying. Limit f of x goes to x0 for any point x0 in this interval, -1 and 1. It's an open interval. Okay. Let f x equal this, the sum of values of c, for which this limit does not exist. Yeah, since this is in 2.2, I think we need to graph it. We can graph the function. You know what? I will solve this question during the exercises of the book, because this is from the exercises of the book. So I will lift it, and I will leave it until time. I think it's question 33 or 33 in the book. Okay, let me go to the problems. These are the problems, and these are the suggested practice problems. In this section, we have what? This group of problems until 10, including 10. Just we need to do it through the table. So you need to fill the table, go to your calculator, put x equal 3.9, put it in this function, find the value of x. Do the same for the rest. In this questions, you will make the table. Huh? You will make the table and then do the same. X goes to 1, I will take values less than 1, values more than 1, and we find then we find the limit. In this case, problems, do the same thing with the table, then you check in these two cases, the limit does not exist. Then we need to explain why. And these problems, we need to do it through the graphs. Let us do the problems, especially the suggested one. This is number 6. This is if you put x, look at this one, he put x equal -0.1 minus, so something less than 1, less than 0, because the limit goes to 0, less than 0, and more than 0. And he checked the table. This is the table. It's very clear. This is by 0.5, 0.5, 0.5. This is expected goes to what? And the same thing from the other side. 0.499988, 0.49999. It's very clear it's going to 0.5, which is half. This is the way to do it. 11, you need to make the table. X goes to 1. I want to so take values less than 1, 0.9, 0.99, 0.9999, and more than 1, 1.1, 1.01, 1.001. I check the value of here. It's very clear it's going to what? This is 0.2499, this is 0.2501. It's like going 0.25, which is 1/4. 14, another problem. This is the function. We did the values. This is 26.999. This is 27. So it's very clear it's going to 27, which is this. Now, these two functions, which is this function, you notice something. Do the same, huh? We are doing the same. As I'm approaching from left, I'm going to 4, but from right, I'm going to what? To 0. So right not equal to left. So the limit does not exist. The same thing here. As I'm approaching the minus, I'm approaching 0. Huh? We're talking about 0. It goes to a big number, increasing 30, 300, 3000. The function is increasing. Going from the other side, the same thing. If you put 0.0001 more 0, the function will increase. So this will go to infinity. So it means increases without bound. Because with that, the limit does not exist. And the limit does not exist. The limit does not exist. Okay. Now let me go to these problems. 24, where we're doing it through the graphs. You have the graph, find the limit. Like in this one, 24. This is the graph. As x approaches 0, 0 from this side or from this side, I'm going to this value, which is 1. So the limit will be 1. 26. This is the graph. As I'm approaching what? 1. So I'm approaching 1 from this side, from this side. It will be here. No, I will be here and there. So I'll take this value, which is 4. So the limit is equal to 4. This is 25. This is the graph for 25. As I'm approaching 2, from this side, I will be there and there. So I'm approaching what? Approaching 2. These more problems through the graph, but in these cases, the limit does not exist. I will do all of these four problems. This is this one. This is the graph. Very clear. If I go from left, I'm talking about 2. Going from right, I will be here. From left, I will be here. So right not equal to left. Because with that, we say the limit does not exist. We say the limit does not exist. And for values of x to the left of 2, it will be -1. From the right of 2, it will be 1. 28. The same problem. Actually, we did it here. This is 28. Same thing. We do the table. One goes to 0. The other one goes to 4. Right and left. Yeah. 29. Or 29, it will oscillate. From the graph, it's very clear. It will oscillate. It will not reach something. Because that, the limit does not exist. All of these cases, the limit does not exist. This one, tan, as x goes to pi over 2. I'm talking about x goes to pi over 2. Going to pi over 2, the function is going where? Either infinity or minus infinity. So left not equal to right. So the limit does not exist. Actually, it's going to infinity, actually, also. So the limit does not exist. So these are the 4 cases. Now, in the next group of questions, he gave you a graph and he asked some questions. So I have the graph. We need to find all of these things. So let us do it. Here, what is f at -2? -2, there is nothing. F at -2, undefined. We don't have f at -2, so this is undefined. So we say this does not exist or undefined. F is not defined at -2. What is the limit? It goes to -2. We have a problem here also. No, this is going to infinity. This goes to -infinity. So the limit does not exist. So the limit, we say, does not exist. What is f at 0? F at 0, it will be this value. It will be, yeah, I think this one. This is open. I think this is open. So this is closed. It's 4. So f at 0, equal 4. What is the limit as goes to 0? Notice from right, I will be here. From left, I will be here. So left not equal to right. So the limit does not exist. What will be f at 2? F at 2 also undefined. I don't have f at 2 because this is open. So f at 2 is undefined. What is the limit as goes to 2? As goes to 2, there is a value, which is this value. Since left equal to right, it will be here or there, so it will be going to 1. So the limit here is equal to, it's not 1, he make it half, no problem, because he think this is 1, this is half. Yeah, you need to fix the graph. So this is half. Who cares? Type f at 4. F at 4, it will be this value, which is 2. There is a value, f at 4 equal 2. But what is the limit as it goes to 4? It does not exist because it will go to infinity. Now the questions 33 and 34. By the way, 33, this is the one which was in one of the exams. So if you graph the function, this is the graph of the function. You know how to graph this function. You graph x squared. This is x squared, but I want it until x equal 2. And then you graph this one, which is just a linear function. But they will, you notice at 2, this will be 4, and this will be 4. This will be 4 at 2. And this will be 4. So because of that, they become like they are only one. They are one graph. And then you graph the other one. Then you graph the rest, which is at x equal y equal 4. From 4 and more. If x gets that equal to 4. If you notice, when the limit does not exist, only here where I have left not equal to right. Other than that, always left is equal to right. So I have it only the function, the limit exists for all values if c not equal to 4. We have problem only at 4. The same thing, graph this function. He did graph it. Where we have a problem, only we have a problem here, not pi. Because left or right not equal to left. Other than that, the function is going smooth. We have no problem. The same thing. Notice at 0, this is 0, and this is 0 also. Because with that, they become like if they are only one function. So the limit exists for all values of c not equal to pi. I hope it's clear. Yeah. In this case, in this part, which is 35 and 36, he wanted to sketch a graph. He gave you some information, and he wanted to sketch a graph. So I want f of 0 undefined. The limit is equal to 0 equal to 4. F of 2 equals 6, and the limit is equal to 3. What I will do, this is possible answer. We can do another one. When he says f of 0 undefined, but the limit exists, and at 0, what will happen? The function can do something like this. At 0 undefined, make it open. But the function continue like this. You can do it like this. You can do it. Notice the same thing. At 0 is undefined. There is an open circle. But right equal to left at 0. You can do it this way, that way. Now at 2, the f of 2 equals 6, but the limit goes to 3. No, he wants the limit equal 4. Sorry. Yeah, he wants the limit. You want the limit equal 4. So this should be 4. So this is open here. Function going like this. Who cares? And this is going down, no problem. If at 2 equals 6, but the limit goes to 2 is 3. So it goes to 3 and continue. This is at 2, and this is 3. And this is 4. But if at 2 equals 6, this is 6. This. So we have if at 2 equals 6, limit as goes to 2, either from left to right is equal to 3 for 0. F of 0 undefined, but the limit as goes to 4 is as x goes to 0, it's 4. So this is the way to do it. The same thing here. They want f of minus 2 is 0, f of 2 is 0, but the limit goes to minus 2 is also 0, but the limit goes to 2 does not exist. So minus 2, it's f of minus 2, 0. This is one graph. The limit exists is equal to 0. Here at 2, the f of 2 is 0, which is correct, but the limit does not exist because left not equal to right. You can do this also, it's okay. No problem. Okay. Then we have a list of problems where they need the formal definition, which is not part of this course. And then we go to what? Yeah, all of these which are cross. We have these two functions, these two questions, where to find the limit for a constant function or for the linear function or for the f of x equal x. It's here. Actually, you can graph the function. If you notice, if you have a function, y equal 4, y equal 4, which is 4 all the way. What will happen as this goes to y? Right is equal to left, it will be 4, for sure. The same one for 60, if you have this function, y equal x. What will happen at x equal by? This is by, so left, right equal to left, and it will be by. It will be the same, like if you are substituting. Okay. This is we did. Now this group we did. I think nothing here to worry about. You need to graph the function. This problem is 22. He wants you to do it what? Estimate the limit by evaluating values near A. So you need to sketch the graph of f and then decide, which is I did here. This is 72. This is the graph. This is the graph. And this is the table. You notice I'm going to minus 0.1. I'm going to 0 from, I need to check the limit, this goes to 0. From left, I'm going to what? To 2. From left, what is it? X goes to? Yeah. Yeah, as I'm approaching how is it this way? Yeah, except at 0. At 0 is undefined because you cannot divide by 0. So it will be, I think there should be a circle here. At 0, it should be undefined. So it should be something like this. Cannot be like that. Okay. So it will be from left, you're going to 2, and from right, going to 2. So the limit is equal to 2. The limit is equal to 2. Which is if x is not equal to 0, and x between minus 1 and 1. So this will be positive, and this will be negative. Yeah, x, yeah, that will be negative. And that will be positive inside the absolute value, I mean. Between fx between minus 1 to 1. So the function, if for any value between minus 1 to 1, it will be what? It will be, this is positive, x plus 1, minus, this is negative, minus x minus 1. When you take it out of the over x. So that give you what? This is minus minus, so it will be x plus 1 plus x minus 1 over x. Cancelled, you have 2x over x over x, but x is not equal to 0. So this will be 2. It will be 2x over x, which is 2. This is what he meant. For a value between minus 1 and 1. If you take a value more than minus 1, it will be a function. Less than minus 1, it will be, just you need to check the sign. Positive, negative, do the calculation. But since we are talking about limit this goes to 0, So I care only between -1 and 1. Okay. So you need to graph the function. Actually, we'll deal with these things later in 2.3. So we did this. The remaining is the true false, which is this group of functions, this group of problems. If it's undefined, does that mean the limit exists? Does not exist? No. Before that, let me do 74. Let me do 74. Then I will go to, yes, I will do this one. Then I will do this true false. This 74. Use the graph to identify values of C for which the limit does not exist. Here, if you look at it quickly, where the limit does not exist, here we have left not equal to right. Okay, so the limit does not exist for sure. At -3, we have a problem. Here, no, the limit exists. We have no problem. So this is the only case where C not equal to -3. And so the limit exists for all values except -3. Here we have a problem here. There is no limit. Also, we have right not equal to left. Also here. So we have it at what? 0 and -2. -2 and 0. This is the only value where the function doesn't exist. Let me go to true or false. We said the limit, he said the function is undefined. Does that mean the limit exists? No. Does not exist? No, the limit may exist. Look at this function. Take any function like this, make it circle. This is 4. So the limit here exists, but the function is undefined at 4. So this is false. Next one, he said if the limit as x approaches C is 0, then there must exist a number k, says that f of k less than this. Is approaching 0, it means f of k will be very small. It means the limit f of x as x goes to 0, as x goes to C, as x approaches C is equal to 0. ايش معناها؟ انه في value بحيث ان f of k يكون مره صغير. وقلنا f of k less than 0.0001. The next one, إذا كان f of c equal L, هل معناها limit equal to L? No. A limit is not related to the value of the function. The same thing. The limit equal L, هل معناها f of c equal L? No. As we said, the limit is not the same as the value of the function. These are two examples. Actually, it's the same example. And look at this example, this function. If you graph it, it will be easier. It's x minus 4. So at 0, it's -4. And at 4, it's 0. This is the line. At 2, it's 0. This is 2. I'll make it open. And the function is 0. Here, the limit exists? Yes, the limit exists. It's equal to this value, which is what? -2. But f of 2 is 0. And the f of 2 equals 0. And the limit as f of x as goes to 2 is -2. So a function is defined at 2 to be 0, but the limit is equal to -2. So they are different. This will tell about both of them, 77 and 78. These last two, 79 and 80, what is the idea? For the square root. For the square root, you need to check from left and right. So when you deal with 0.25, there is a left and right. So we just substitute, we get 0.5. Since this is square root 25 over 100, which is 5 over 10. Okay, 0.5. But notice, if I want to do the limit, x goes to 0 from the square root. From right, yes, we can do that. But from left, we cannot do. So also we need the function is not defined. He said the function is not defined an open interval containing 0. Because the function is not defined as this goes to 0 from left. And with that, we say the limit does not exist. Here, the limit does not exist. I think that's all for 2.2.